Okay, so what is a monoclonal antibody? So a monoclonal antibody is a protein molecule with a specific shape to it, and it's going to lock on to a specific antigen. So the antibody will lock on to the antigen. Now imagine this antigen, it could be a virus, this antigen could be on a virus, this antigen could be on a bacteria, or this antigen could be on a cancer cell, but it has got a specifically shaped antigen. Now, your lymphocytes with their big, big nucleuses, these lymphocytes will detect that antigen and make a complementary antibody. Okay? And the antibody will lock onto the antigen and then it destroys the cell or it destroys the virus or the bacteria. Now, we can design these antibodies. We can make antibodies. And how you make them is you take a mouse, some of you might not like this, and you inject it with an antigen. So I'm going to inject it with a square antigen. Now, inside the mouse, it will have lymphocytes, and these lymphocytes will make antibodies. Okay, can you see? They'll lock onto that. Happy days. The problem is the lymphocyte does not divide. So if I want to make lots and lots of these, I can't really do it much now because these don't divide. So what do? I remove the lymphocyte from the mouse. Okay, this lymphocyte makes this antibody. So I'm removing this lymphocyte. I'm removing it and I'm joining it on to a cancer cell. Now, why on earth would you use a cancer or a tumor cell? Well, the thing they can do is they can do cell division, uncontrolled cell division. Now, I want this to divide. I want the lymphocyte to divide because it'll make lots and lots of antibodies. So if I mix the lymphocyte, if I join the lymphocyte with the cancer cell, I make a cell called a hybridoma. Now, this is like a supercell because what the hybridoma can do, the hybridoma can divide, but it can also make the antibody that I want. So a hybridoma is brilliant. Okay. So you let the hybridoma divide by mitosis. Okay, let it divide by mitosis, and you get lots of hybridoma cells. And those hybridoma cells will make lots of antibodies that are exactly the same shape and size. Can you see? They're all exactly the same. And these are your monoclonal antibodies. Okay. Now, what can I do with a monoclonal antibody? You can do loads of stuff with them. You can attach a drug to them. Okay. And that drug might be kill a cancer cell. You can attach nutrients to it, so you can target specific cells with specific nutrients. You can attach specific ions, metals to them. So they're really great ways of targeting specific cells in your body. So again, let's just check that you've got this. So any protein that doesn't fit your body is called an antigen. We'll call it a foreign antigen. And what will lock onto it is an antibody. Now, what makes the antibody? The lymphocyte. Okay, so the lymphocyte makes an antibody that locks onto an antigen. Now, if I want to make lots of these, then I have to take the antigen, inject it into a mouse. The mouse will then make lymphocytes. I'm going to sneeze. Excuse me. It makes the lymphocytes, and the lymphocytes make this antibody. But the problem is the lymphocytes don't divide. So I'm going to be limited how many of these I can make. Therefore, I want to take this lymphocyte out of the mouse that makes these antibodies and join it to a cancer cell. Now, why a cancer cell or a tumor cell? Because they can divide. And the lymphocyte and the cancer cell together makes a hybridoma. And the hybridoma will divide and make the antibodies, okay? And then you can make loads and loads of them. Why? Because the hybridomas divide. It's not any old hybridoma cell. It's making this particular antibody. Okay, so that's how you make a monoclonal antibody. Monoclonal antibody means they're all exactly, absolutely exactly the same shape and the same size. Monoclonal antibodies. Okay. So keywords you really need to be clear on is antigen, antibody, lymphocyte, tumor cell, because it can divide, okay, forming a hybrid oma, which makes the monoclonal antibodies. So there's your keywords for this topic. Okay, I hope that's useful, folks, and I'll see you soon.